Hello, I'm going to talk to you a little bit about different kinds of sex determination systems. You're likely familiar with the one present in humans, which is the XXXY system. But what I want to tell you is that the reality is this is only one of many strategies used in animals and indeed in plants to determine sex. And you're probably familiar already with how the XX and XY system works. But let me just point out a couple of things. Please note that chromosomes occur in pairs in mammals. There's two X's. And in the case of the male, there is an X and a Y. So what happens is when we make the sperm and the egg, it only receives one copy of each chromosome. The pair is split. And what we say is that the female is what we call the homogametic sex. In other words, the female can only produce one type of egg, and she can produce an egg that carries an X. On the other hand, the male is what we call the heterogametic sex. The male, half the time, in theory, will produce sperm carrying, will produce sperm carrying an X chromosome, and half the time they'll produce sperm carrying a Y chromosome. So if this egg is fertilized with a Y chromosome, we will get a male offspring. And so if we cross that, we will get a male. And if this egg is fertilized with an X chromosome, we'll get a female. So I'm thinking you're likely familiar with this system already. I want to tell you about some different systems because they're kind of interesting. One system that's kind of fun to learn about is a system called the ZZ system. And this system is used in birds, and it's also used in moths, so things like chickens, moths, and they don't have X and Y chromosomes. And their chromosomes are very different. Their sex chromosomes are very different. They're called Z and W. And what's interesting about this situation is that in the case of chickens and moths, the female is the one that has the two different chromosomes and therefore is responsible for determining sex. The male is the one that has two identical chromosomes, thereby producing just Z-bearing sperm, just one type of sperm. And in this case, we say that the female is the one that determines the sex. So these are females and these are males. So it gets a little bit confusing, isn't it? And again, we will say in this case that the male is the homogametic sex and the female is the heterogametic sex. So there's two different strategies, and if you bear with me, let me tell you about a third. And the third strategy is one that's used in, I'll pick another color, is one that is used in insects, and I'm excited to tell you about that. And that system is called the XO system. XO. XOXX system. And this is in insects. Now, in this situation, similar to humans, we note that the female is the one that has the two X chromosomes, just like we described earlier. And the male, in this case, just has one X chromosome, and the O doesn't stand for a chromosome called O. The O refers to the fact that males in many types of insects just carry one X chromosome. The males have two of all the other chromosomes, but they just have one X chromosome. It's kind of interesting to think about. It's kind of like they lost the Y chromosome. So in this case here, again, just like in humans, the females will produce eggs that have an X chromosome, and the males will produce sperm that either have an X chromosome or no chromosome at all. And I'm just going to leave an empty space. okay? And these guys here will be the males, and these critters here will be the females. So that's a little bit about sex determination. So if you look out for my next video, I'm going to tell you a little about really, things get really crazy in bees, and we're going to talk about something called haplodiploidy, okay?